it reduces oxide of copper, zinc, etc. to their respective metals. Use of hydrogen. It is used in the manufacture of ammonia. That is done in the upper process. It is used in filling balloons due to its low density. Take note of that. Why it is used in filling balloon is because of its low density. 3. It is used as raw material in the production of margarine. Yes, as in the organic rind. You use it to produce as a raw material for the production of margarine. 4. Liquid hydrogen is used as a rocket fuel. They use as rocket fuel. The one that is liquid hydrogen that is used as rocket fuel. 5. It is used in oxy-hydrogen flame to melt metals. Why? Simply because a lot of heat is produced in the process. Questions. An isotope of hydrogen commonly referred to as heavy water is A. Protium, B. Deuterium, C. Tritium, D. Basic water. 2. All except one metal can displace hydrogen from water or acid. A. Zinc, B. Silver, C. Potassium, D. Heated magnesium. 3. Which of the following metals will not give hydrogen with dilute hydrochloric acid? Answer to question number 1. An isotope of hydrogen commonly referred to as heavy water is deuterium. Take note of that. It is deuterium. 2. All except one metal can displace hydrogen from water or acid. The only one that will not be able to displace hydrogen from metal, from water or acid rather, is silver. Simply because silver is less reactive than hydrogen. If you check your electrochemical series, you will discover that silver is below hydrogen in the electrochemical series, and therefore it is less reactive than hydrogen. So in that situation, it will not be able to displace hydrogen from water or acid. Then number 3, which of the following metals will not give hydrogen with dilute hydrochloric acid? This question is also testing reactivity. If you look at the options, you discover that copper is below hydrogen in the electrochemical series. Therefore, copper will not be able to displace hydrogen from hydrochloric acid because it is less reactive than hydrogen. Oxygen. Oxygen is placed in group 6 and period 1 in the periodic table due to what? Valence electron and number of shells respectively. General properties of oxygen: it is an acid producer. It reacts with most metals to produce what? Acid. Or it reacts with even hydrogen to produce acid. It is also important in breathing, etc. The electron configuration of oxygen is 1s2, 2s2, 2p2. Industrial preparation. Oxygen is prepared by the fractional distillation of liquid air. Laboratory preparation of oxygen from thiazochlorate 5. It decomposes on heating to give potassium chloride, oxygen, usually in the presence of manganese 4 oxide. So what that one is saying is that potassium chlorate, which is a solid in the presence of manganese 4 oxide, MnO2, which is a catalyst, it will now produce KCl solid plus 3 moles of oxygen gas. So in this situation, you have a scenario like this. So this is the decomposition. So decomposition on heating, when it is heated in the presence of manganese 4 oxide as catalyst. From hydrogen peroxide, the catalyst manganese 4 oxide decomposes this compound to give water and oxygen. So you can also, by virtue of hydrogen peroxide, so you also have this oxide here. Then in this situation, you have 2 moles of water, gaseous, plus O2, gaseous. So hydrogen peroxide. 2 moles of hydrogen peroxide liquid. So in this situation, you have a scenario like this. So these are the 2 ways by which oxygen can be prepared, by the composition of potassium trichloride 5 and also by the composition of hydrogen peroxide. Physical properties of oxygen. It is a diatomic gas which is colorless, odorless, and tasteless. 2. It is neutral to moist litmus paper. 3. It is slightly soluble in water. 4. Gaseous oxygen is denser than air. 5. Gaseous oxygen liquefies at minus 183 degrees Celsius and solidifies at minus 225 degrees Celsius. Chemical properties of oxygen. Oxidation. Carbon combines with oxygen to form carbon 4 oxide. 2. Reaction with metals. Potassium reacts with oxygen to form potassium oxide. 3. Reaction with non-metals. It reacts with sulfur to give sulfur 4 oxide. 4. Combustion. It combines with ethanol to give carbon 4 oxide and steam. And this reaction is very significant in organic chemistry. Use of oxygen. It is required in respiration. 2. It combines with ethane to give oxyethane flame at 2000 degrees Celsius, which is used to melt metals. What is responsible for this melting ability? Because a lot of heat is produced in the process. Liquid oxygen and fuels are used as propellant for space rockets. 4. It is used in the steel industry for the removal of carbon, sulfur, etc. It is used in the manufacture of important compounds such as tetrasulfate 6 acid, triazonitrate 5 acid, etc. Question. The most abundant element on Earth is A. Nitrogen, B. Helium, C. Silicon, D. Oxygen. 2. Most acid anhydride react with water to form acid. Which of these is a mixed anhydride? Laughing gas, B. Nitrogen 2 oxide, C. Nitrogen 4 oxide, D. Sulfur 4 oxide. 3. Which of these is not an amphoteric oxide? A. Zinc oxide, B. Aluminium oxide, C. Tin 4 oxide, D. Sodium peroxide. Then number 4. Oxygen in air can be absorbed by passing it through a caustic soda. A. Caustic soda, B. Fused calcium chloride, C. Alkaline pyrogallol, D. Washing soda. The most abundant element on Earth is oxygen, while in the atmosphere it is nitrogen. So the most abundant element on Earth is oxygen. So the answer to question number 1 is D. Oxygen. 2. Most acid anhydride reacts with water to form acid. Which of these is a mixed anhydride? The only mixed anhydride that we have here is nitrogen 4 oxide. Nitrogen 4 oxide is the only mixed anhydride that we have here. So therefore the answer is C. Question number 3. Which of these is not an amphoteric oxide? The examples of amphoteric oxide are zinc oxide, lead oxide, aluminium oxide, and tin oxide. So these are examples of amphoteric oxide because they are amphoteric because they share both basic and acidic properties. So in that situation, which one will be odd here? The odd one here will be sodium peroxide because it is the only one that does not belong to this class. And therefore, the answer is D, sodium peroxide. Oxygen in air can be absorbed. Oxygen in air can be absorbed by passing it through A. caustic soda, B. Fused calcium chloride, C. Alkaline pyrogallol, D. Washing soda. The only substance that has affinity for oxygen is what is known as alkaline pyrogallol. Alkaline pyrogallol. Pyrogallol. So it has affinity for oxygen. So therefore, the answer to question number 4 is C, that is alkaline pyrogallon, because it has the ability to absorb oxygen from its mixture. Halogens. The electron configuration of halogens are similar in that they belong to group 7 in the periodic table. Thus, have nearly the same chemical properties. They are called halogen because they are what? They are salt formers. These elements are fluorine, chlorine, bromine, and iodine. Chlorine is the most important element of this group and thus is treated intensively. That means the chemistry of chlorine is very vast compared to other members of this group. Laboratory preparation of chlorine. It is prepared in the laboratory by the oxidation of concentrated hydrochloric acid with manganese 4 oxide. So if you have manganese 4 oxide, it is a solid plus hydrochloric acid, aqueous. It will give manganese chloride plus. So in this situation, you have chlorine, which is one of the components, then you have water. So it's balanced now. So the one way of preparing chlorine in the laboratory is the reaction of manganese 4 oxide with hydrochloric acid. Industrially, chlorine is prepared by electrolysis of brine, that's concentrated sodium chloride.